So after today's presentation, you will be able to answer the following questions. So what is the HAZOP itself? What is the background of the HAZOP? The HAZOP methodology. You will be able to understand how the worksheet can look like when you fill it. What is the LOPA study, LOPA methodology, and LOPA worksheet sample? Okay. HAZOP actually is an acronym which stands for Hazards and Operability Study. The purpose of this study is to assess any process hazards that may arise and any potential operating problems by using a serial of the guidewords and arising from them deviations from normal process conditions. So why we're doing it? First of all, we're doing that to identify any possible causes of potential safety or environmental hazardous scenarios and major operability problems. Identify the potential consequences, how this will affect to the process, what will happen afterwards. Check and identify what hazards we have in place, if they're sufficient, if they are enough, or we need to have additional one to keep our process safe. And of course, make recommendations to reduce the risk which has been identified during the HAZOP and to address any major operability problems. Let's go back a little bit to history. This technique firstly has been like in a different form created in 1960s at the Imperial Chemical Industries of the UK and was actually based on the critical examination technique. At that moment, a team of 3 people met together to study the design of a new phenol plant. This technique only started to be more widely used within the chemical process industry after the Sphera disaster in 1974. And before that, before the disaster, the chemical engineers, IChemE, started to provide the safety course, which after the disaster became widely popular. I recommend you to go to YouTube if you don't know the history of the Sphera disaster to be familiar of it, because learning our past mistakes allow us to not doing them in future. Okay, after that, the first HAZOP paper was published in 1974. And today, the main standard which is used, the only standard which is used is IEC 61882, which is International Electrotechnical Commission code for the hazard and operability studies. So this one is a really good guide if whatever you want or whenever you will be in future involved in the HAZOP, please just go through it. It will refresh your understanding, and it will refresh your memory, and will give you really good explanation how everything should go in the process step by step. Okay, so what in general HAZOP itself is like a meeting, a gather of few engineers from different disciplines to assess the possible risk and possible consequences that may harm safety, that may harm people or environment. And when I'm saying the meeting, I mean that you have few amount of people that must be led by one person to be able to come to one conclusion. So the core team, which mostly 100% should be attending the meeting, are, first of all, is the HAZOP leader and facilitator. Think about him as a leader of the meeting. This person should have a very good experience in the process, should be accredited, should be well trained, and should perform because on his performance depends the I don't know, the clearance, the best outcome of the session itself. So HAZOP leader is the one who will lead whole teams through the session itself. And at the moment when there will be contradiction, opinions, or he will come up with a final solution, final idea by listening to different sides. So he shouldn't be biased by any of the sides. So that's why a HAZOP leader and facilitator should have an experience and should not be involved or work for the operating company, for the company who actually performs this HAZOP for their facility. So that should be totally different person to avoid any conflict of interest. Next one is a scribe. Look at this person as someone who, like a secretary, someone who will sit with this team, the whole meeting, in order to capture all the data that has been discussed, has been assessed, has been agreed during the meeting, capturing all causes, consequences, risk ranking, and etc. Then we go to the process and mechanical engineering teams. Those one are the ones who will be responsible in understanding on the process design of this node, or on the design of the vessels, and etc. So their understanding and their experience is very valid during the session. Of course, you need to have the process safety engineer and day-to-day operations team who will need to be aware how this may affect the normal operation of the plant. Okay, this is about the HAZOP team itself. And let's move to the next slide, which I will go through firstly, and then we will go to one step, one by one. So below are the most important HAZOP study steps. First of all, before the session, you need to specify node and identify it on P&ID. P&ID are piping and instrumentation diagrams. It's the layouts of the plan. And with all the data for piping, instruments, vessels, and etc. Specifying the nodes is when you are setting the beginning and the end of the node, like the beginning and the end of the study. You can't capture all the data in one session. Therefore, you need to separate the nodes. After you do that, you are defining the design concept. Then you are selecting parameter and guidewords applicable to your node. Using the parameters and guidewords, you are creating deviation, which then lead us to identify any possible causes that will lead to this deviation. Then you identify and assess consequences and assign severity for each of the consequences. Afterwards, you assess whether you have any safeguards, put them in place, put them into the record, add additionally likelihood to this specific consequence, and you're generating a risk rank. Afterwards, you are adding recommendations if needed. After all of that, you are moving to the next guideword, next deviation, and then you're repeating all the steps for each node in your study scope. So let's go one by one then. Specifying node and identifying it on P&ID. So, as I previously said, node is a section of the process P&ID that can contain piping and vessels and reactors, separators, exchangers, etc. This is done in order to grasp on a very one specific area, not complicating the study and not complicating the session. Thus, sometimes you can see that notes are too small or notes are too big. In order to not to do that, they are trying to moderate them. So people will not be exhausted during one session, and there won't be any confusion. There are different criteria on selecting transition to the next node, and some of them include like change in design pressure and temperature rating, and change in state like liquid, vapor, and etc. Node selection, this part of the HAZOP HAZOP study shall be done prior to the study itself. It's like preparation to the study. This is done most of the time by HAZOP facilitator, which then marks them up on the PIDs. And before the session, these are printed out and like a few copies and delivered to all the attendees. So during the session, they can follow the process through these PIDs. So, okay, we're moving to define design concept. Why it's important? Like before the study itself, everyone in the room who will join the session, who will involve in the HAZOP process, need to understand the parameters of this node, parameters of the design. So most of all, like this is the design temperature, design pressure, operating temperature, operating pressure, etc. The limits of the design shall be described. Most of the time, this is done by the process engineers, and this is also shall be recorded in the worksheet itself. Like there will be a separate section in the worksheet when you will need to put all this data down. So again, design, concept, intention describe how a node is expected to operate and what is the purpose of the system, including the relevant parameters such as design flow, temperature, pressure, and level. So let's move next then to the parameters and guidewords. This is one important part which need to be specified for a node. So what are parameters and guidewords? So you can see in the screen the parameters which are applicable for different nodes. They can be different. This includes, but I just give like few examples of them, but there are lots of them. This includes the flow, pressure, temperature, and level. This is parameter. The guide word is when we are using such words as more, less, no, reverse, and etc. In combination, they give us deviation from the normal process condition, which can be seen as more flow. For example, on this specific pipe, you are receiving more flow than usual, and then you need to assess what is the reason of it. Okay. So after you identify all required parameters and guidewords for your node, you are putting them down. You are putting like you have flow and then specific deviation, more flow. And after you identify more flow, you are going to the next step. And next step includes the causes, like identify possible causes. Okay, you identify the deviation. And now you need to set the reason why this deviation occurred, like why you have more flow in that specific area. And the reason of it shall be identified and captured in the HAZOP worksheet with relevant equipment and instrumentation tags. Also, you should be aware that there can be several causes that can lead to one deviation, like more flow can be because of the fail of the control valve upstream of your node or any other reason. what can be else? That's not a good example. Okay, but again, there can be a few different causes for one specific deviation. We will go that when we will review the example of the worksheet. Okay, you identified the cause of the deviation. You put that down, like failure of the control valve upstream of the piping, upstream of your node. And afterwards, you are identifying and assessing consequences and assigning severity of each consequence. So what is the consequence? Consequence is what is the outcome? Okay, you have more deviation, more flow on this line. Okay, what will be the outcome? Can you overfill the vessel up downstream, like the vessel in your node is one of the consequences. If you're overfilling the vessel, what can happen? Okay, so this is really, really significant area of the HAZOP because when the main rule here is like you are assessing this, assuming that you have no safeguards in place. So you have more flow, it's overfilling your tank, overfilling your vessel, and what will be the worst possible scenario? Will it rupture? Where will be there any leak? Where what the chemicals, what the fluid is inside that that piping and inside that tank, and it can lead to different outcomes, to different consequences: rupture, jet fire, explosion, vapor, VC, and etc. and etc. All the worst possible scenario should be captured because this gives us the severity of the consequence. And thus, you are not assessing like you have more flow and you have some safeguards to prevent it. No, you are assessing that every single safeguard fail, and then this gives you the worst possible consequence. After you're doing that, you assess severity of the consequence. Different companies are using different risk ranking metrics. If you are working, for example, with BP, you for example know that well-known 8-to-8 risk ranking matrix. You are working for another company, it gives you the other risk ranking matrix. And for example, if you are working if two companies are working together and once the rules and regulation on one company are more strict than regulation of another company, we are following the most strict regulation. We are accepting the most strict, precise documentation and procedures. So, okay, that's regarding the matrix for severity. It can be numbered, it can be colored, it can be totally different, but it goes from the less severity to the high severity. Less severity where there can be just like no injury, nothing happened. That's regarding the safety area, because your severity can affect health and safety, environmental, financial. It has few different impacts, and depends on that, the severity will go from the less to the highest point. When for example, for safety, there is no I'm very sorry. And when the severity goes from no possible injury to any person and to the highest point, to the fatality of few people and the possibility to collapse of the platform and etc. So when you identify your consequence, you are assessing how possible that this will affect any people around it. You are then specify the severity of this consequence. So how possible if that you will have, because of that leak, to the sea, leak to the ground, more additional venting to atmosphere, and etc. And all of that will affect different category of consequence, like, as I said, health, safety, environment, and financial. Let's go to the next slide. After you identify the consequence, you already know your worst credible scenario, then you can go back and identify what type of safeguards you have in place, already have there, to prevent this from happening. So you go again to your worksheet and put in any possible safeguards, like basic process control system, safety instrumented system. You have in place pressure relief valves, rupture discs, deluge system, fire and gas detection system, alarms, and etc. All of them will prevent this deviation from to occur. You need to put them in place and count them. After you're doing that, you can the risk rank of your risk rank your possible deviation. Risk rank your possible cause. And how is going on? So you already have the severity of your consequence. You have identified the safeguards which will eliminate the likelihood, and then you are assigning the likelihood for the cause, taking into account the safeguards which are already installed and already are in place. After that, likelihood, like this is like an example of risk ranking matrix, which is very, very generic one, and is totally different from company to company because everyone, that is very, very high level of understanding of it. Like consequence, like insignificant, that's what we said before, the severity of consequence. Insignificant, minor, moderate, major, severe, like moderate in some companies, in some specific, their procedures will identify that moderate can, for example, lead to injury or death of one person, which could be nearby of that vessel, for example. And that's why you will go to the severity of this area, and afterwards, how possible this could happen, how possible that your cause will happen. Like there will be no flow because of the stuck of for example, that control valve. And assessing that, taking into account how often that happened previously in industry, and for example, that's a common thing, that's a possible thing. Summarizing that, like after you're assigning the likelihood, you are using the risk matrix to identify the risk ranking. Like you have the likelihood, you have the consequence, and together you go to the point where it shows high. Most of the time during the coloring of the risk ranking, then you are going either to direct it to LOPA, for example. Again, different companies have different criteria for that, but sometimes as soon as you go to the one specific area, for example, you are going to moderate for safety or environmental consequence, automatically it will need to go to LOPA. Even you identify the safeguards here, it will still go to LOPA, and you don't need even to risk rank because this will be done further in LOPA. If it's not automatically accredited to LOPA, then, for example, you are in this area, it's a minor consequence, is likely, what is likely, it's really high. You are just risk ranking this area and add it to the HAZOP worksheet. You put it into the HAZOP worksheet. And afterwards, you are considering whether you want to decrease the likelihood, whether you want to add additional safeguards to improve this area too. If there's any possible opportunity to decrease the likelihood of this event by adding any additional safeguards. So that's the likelihood. After you are assigning the likelihood, as I said, you are going to the LOPA. You don't even need to assign likelihood if it's already because of severity is LOPA credited. Here you are directly going next to the to selecting the parameter guidewords to a new one, and if it's not accredited to LOPA, for example, you go further on this HAZOP worksheet. You are adding recommendation if applicable. Okay. So our recommendations, as I said, are raised if it's deemed possible that there is an opportunity for further risk reduction. You assess that it's in one specific area on risk ranking matrix, and you think, okay, I can reduce the likelihood of it by adding additional safeguards, then you can raise the recommendations. Two important rules for recommendations are they shall be assigned during the session, and second is they should be concise and easily readable, easily understandable for anyone outside the HAZOP team. So if that was assigned to my team, for example, I didn't attend the session, but the person that worked before me left the company, and I'm now at the moment responsible to close the action. When I read it, I need to easily understand what it's talking about, so there won't be any confusion for me from the initial saying of the HAZOP team. Okay. Next one. Okay. Let's like this very simple HAZOP worksheet example. So let's again remember how we went through all the steps. We had a guide word. This is put as a guide word here, but it's a combination which lead to guide word, which lead to deviation. So we have no material. The deviation is no material A flowing to that area. Then you are going identify the deviation. You're going, what is the possible cause that will lead to no material flow? It means that the supply tank, which is upstream, is empty. What the consequence? We identify the cause of this happening, and then we're identifying the worst credible scenario or worst credible consequence is no flow of A into reactor, and this will lead to explosion. So this is our consequence. After identifying that, I couldn't find any example on internet with the risk ranking here. I will give it in a empty one. I will show it in an empty one so you can see that one, how it looks like. So you assess the consequence, you have already the risk ranking, and it shows here that after reviewing this section, it has been identified there is no existing safeguards to prevent this from happening. So the comments, the situation is not acceptable, and it leads us to raising the action or recommendation. So consider here is additional action which shall be implemented and is allocated to a person. Consider installation on a tank A level alarm plus a low level trip to stop pump So you are adding two safeguards here. First of all, you have low-level alarm, which will notify operator that the tank upstream is close to be empty. And second of all, on reaching low level, there will be a trip that will close the pump downstream downstream of the tank, and will not it from will prevent it from being empty. And I suppose this will need to be connected then somehow to reactor, which will send signal to reactor as well. I can't see it here anywhere, but you can notify the reactor that it will not receive any feed of A because the tank is empty. But probably they can be done manually done. Okay, that's one example how actually the HAZOP goes from the start to the end. That is for one deviation. We review it from one deviation. And I can't see any risk ranking here. Let me see if we will have it here. No, again, we have guideword, deviation, cause, consequence, existing safeguards, recommendation, and action which will outstanding with one specific person. Okay, so that's example of the PHA Pro software. Most of the time, in different industries all over the world, PHA Pro software, which is developed by Sphera, is widely used to collect to put down all data from the HAZOP study. So you can see here like how it looks like. Again, guide word, deviation, cause, consequence, safeguard. This is severity. This is likelihood. This is risk ranking. So your consequence here, when you have a cause, consequence can be 1, 2, 3, 4, or it's consequence Y, like consequence depends on the safety, consequence depends on the environment, consequence depends on the financial impact, and etc. And it all will have its own severity, and likelihood will be generally like the same. But severity for all of them will be will be different. Yeah. Okay, that's regarding the HAZOP itself. Do you have any questions at the moment? I can see one before we'll go to the LOPA. Okay. Units are not units. Do you mean units as separators, tanks, and etc.? Because nodes can include them. Farid, can you speak, please?
Yes, I mean group of equipment like separators, pumps for specific unit. Can we say they are nodes or?
You can't specify like the unit itself as a node. You are stating that you're not starting from this area to this area. It can include unit. It can include unit. Of course, it can include separator. It can include exchanger, and etc.
Okay, thanks. I have one more question.
Yeah.
So let's say emergency situation happened and there is no flow of, let's say, material A. Do the engineers refer to this HAZOP sheet, or it's just for informative, for informing engineers for the situation before the emergency situation happened?
This HAZOP sheet is then used, first of all, this HAZOP sheet is used by, you can show that it's asked to add additional safeguards. So from this happening, you have an emergency situation, for example, that tank was has a low level there, we added additional safeguard there. There shall be operation procedures which states saying you that if this happens, you should act in that or that way. Operations team have their own procedure which they follow in case of emergency.
Clear sense.
Mm-hmm. Okay, anyone have any other questions? It's nice. Okay, so this was related to the HAZOP session itself. Let's move to the next slide, which give us understanding what is LOPA. Because during this session, I mentioned few times that LOPA, some of the HAZOP consequences, when they are ranked the severity reached specific level, they automatically may proceed to LOPA, and you don't need to put any likelihood for them. Why? Because that will be done during the LOPA process. Because it's already said that the severity is high enough and we need a very specific safeguard to prevent it from happening. So what is LOPA? LOPA is an acronym standing for Layers of Protection Analysis and is an assessment where we assess the effectiveness of IPLs, which is independent layers of protection, in reducing the frequency and likelihood of hazardous event. In reducing the frequency and likelihood of hazardous event is evaluated. So the first LOPA book was developed by CCPS committee from 1997 through 2000 and was published in 2001. So here I will just give you the quick steps through all the steps of the LOPA, and then we will look into the example spreadsheet so we can easily understand that one. So after we identified hazardous scenario, we identified it during the HAZOP, and we gather all initiating cause of the LOPA in one scenario in HAZOP. So when we identify the cause in the HAZOP, you remember that, it would lead to one specific hazardous scenario, which is a consequence, safety consequence, environmental consequence, and etc., etc. So one specific hazardous scenario will be created during the HAZOP, and causes which lead to same specific hazardous scenario will be added to this hazardous scenario. So you gather all causes, which will be the called there in initiating causes under the scenario. So after you are doing that, you are identifying the scenario consequence, but that has been already done during the HAZOP. Consequence will be the severity of this scenario, which will be all the same across the HAZOP with the same outcome. And after that, you are identifying the alarm TML. What is TML? Is a target mitigated event likelihood. So when you see already have a severity of a specific event, you know that the TML, the possibility of this happens, should not exceed this area. Do you remember our risk matrix? Let me show it like there. 1 second. So that will be easily seen there. For example, you identified the consequence moderate, and you don't want this happens like oftenly than unlikely. It should be less. It should be less than that. It's a very like specific, a broad explanation because it doesn't give all data. It's not given all data like on this risk ranking matrix. Okay, but after you, what is how you are in other way can understand TML? It's like alarm, like you can't decrease the possibility of this happening by adding safeguards lower than that, because afterwards it will not be practicable. Like you are adding additional steps and don't change the likelihood more and more. So for all of them, for all the consequences, for different companies shall have their specified alarm and TML, which then shall be used during the LOPA. So you have on your spreadsheet TML, like your target, which you need to achieve. You need, and that's totally based on scenario consequence severity. After that, you have an initiating cause. Let's go cause by cause. Like initiating cause, this happens. How possible this can happen? You are adding the likelihood for this initiating cause too. So you are assessing how often this happens in industry. How often this valve, for example, fails in industry. You're adding likelihood to that one. After you're adding, identifying the likelihood of the initiating cause, you start assessing IPLs. If previously there were captured few safeguards in HAZOP, as you did it in HAZOP, you can carry on them to LOPA and then assess whether they are separate IPLs or they're not. After doing that one, and all IPLs have their probability of failure on demand. Probability of failure on demand, how possible these safeguards will fail. And it also is expressed in a numeric, in a number, which, how can I explain that one in simple terms? The safest IPL, it will have the lowest PFD number. As safer it is, lowest will be, it will come from 0.1 to 0.001, 0.001, and etc. So it will be like the more reliable it is, the lower will be its probability of failure on demand. So it will withstand and like support this situation and protect this equipment from failing. This initiating cause from this scenario from happening, because it will stand as a protection layer. So again, maybe that's a little bit confusing. So you have an IPL which has very low probability to fail, like their likelihood to fail is very low. It means that they are very, very reliable, and they will withstand to in this hazardous scenario and will act as a layer of protection. So after you're identifying, listing all IPLs, you're calculating the you already know the likelihood of initiating cause. You know the PFDs of the IPL. You are multiplying this data. You are multiplying your initiation cause likelihood with the PFD of IPLs. And this data will give you the result, the MEL, AL, sorry, of this scenario, not scenario, that for this specific initiating cause. And this likelihood you need to compare with TML. And as soon as it will be once again, let's go back to that because I was speaking about one initiating cause. If you have the few initiating cause under one scenario, you are calculating likelihood or multiplying initiating cause to the PFD of the IPLs, that for one initiating cause. Same for the second, same for the third, same for the fourth. And then these results you are summarizing, and this gives us the likelihood of the hazardous scenario. And this likelihood shall be compared with TMEL. In case you have one initiating cause, yes, then you are checking its data multiplied with PFD of IPL to the TMEL. Otherwise, you need to take into account that several initiating causes can lead to these hazardous scenarios. So you should summarize them and show whether this will be less or equal to TMEL. Like you are saying that after multiplying and summarizing, it will be less that your required data, it will be less than TMEL. Then you can skip next step with a recommendation and go to the next scenario. You already assessed, you are assessing that, yes, you have this hazardous scenario, your TMEL, your target is that, but with all the safeguards and all the initiating cause, you're not exceeding the likelihood of your scenario is not exceeding the TMEL. So we're totally happy, we're okay, we can move to the next scenario. If you don't, then it means you need to raise a recommendation for an additional independent protection layers to that specific initiating cause that draw us back and lead to increase of the likelihood of the whole scenario. Do that until your likelihood of the scenario will not be less or equal to TMEL. Then you can go to the next scenario. This is LOPA. So let's go to next part, and I will show you just like example of IPLs, why we're calling them IPLs, and what is the difference between IPLs and safeguards. IPLs are independent protection layers, and you can see on the screen a list of the active and passive IPLs, such as basic process control system, human response to alarm, pressure relief device, safety instrumented system, that active IPLs. Then it's passive IPLs, dike band, open vent, blast wall, bunker, flame and detonation arresters, and restriction orifices. So why we call them IPL? So there are few requirements. The basic saying one we're calling that IPL, that's that this safeguard must be independent of the initiating event, such that a failure associated with the risk will not cause the safeguard to fail. Also, the safeguard must be testable, verifiable using industry standard. Safeguard must be specific in detecting a potential hazard and taking action to prevent the hazard from occurring. And safeguard must be capable and available at least 90% of the time. Also, the safeguard must increase the risk reduction factor, which is the opposite of the probability of failure on demand, to a value greater than or equal to 10. So this is our IPLs. And example of LOPA. Let's go through all the steps which I described before. So it will be maybe a little bit more understandable. So first of all, that's our scenario. Scenario have different initiating causes, 1, 2, 3. They come from different areas from HAZOP. They come from different areas from HAZOP, and all of them lead to the same scenario. And all of them lead to the same scenario with have the same severity consequence. So you have an impact like overspeed of the rotor leading to fracture of casing. Initiating cause for speed control system fails. First of all, there is a likelihood of these initiating cause. How often this happens? The likelihood is 0.1. Okay. Then you have the protection layers, IPL, independent protection layers. General design, you can't take credit for them. Control system can't take. Alarms, etc. No. Additional mitigation, restricted access. There are a few, probably they didn't mention it here. There are a few which they take account from, and their PDF, probability of failure on demand, is that one. Additional mitigation. Oh, sorry, that one. Additional mitigation. This is different types of mitigation which can also be used, which PDFs can also be used. And after that, you have intermediate event likelihood. That one. So I can't see if tolerable frequency. Okay, I can't see it here at CML, so it's a little more difficult to compare. Okay. Oh, sorry, that's it. CML. Okay, you have that one. How you calculate them? You calculate multiplying that gives us 10 minus 3. Then for the second initiating cause, you're doing the same. Multiplying this, it gives us 10 minus 3. Then the clutch failure, you are doing the same with this area. You are multiplying these segments, and it gives us 10 minus 4. So total, when you are calculating the event of that, the total event, to intermediate event likelihood, you are having 10.1 to 10 minus 3. But your mitigated event likelihood is 10 minus 5. So this one is lower than that one. So in order, if it will be vice versa, then we will be just happy and will not go to the recommendation. We won't need any additional recommendation, any additional IPL to bring this scenario to require TML. So what are we doing? So we are adding additional scenario like you need to have the independent protection layers with specific seal rating, which will be 5 to 10 minus 3. By multiplying, this will lead us to the MEL, mitigated event likelihood, which will be then lower than tolerable event likelihood. If we will multiply that one to that one, minus 6, 10, it will be 10 minus 5, so which will be equal or less than the 10 minus 5. Yeah. Okay, any questions on that one? So you basically understand the concept, how the steps are doing in the LOPA, how this has been performed. Please let me know if you have any questions.
I have one question.
Yeah.
What does restricted access in additional mitigation means?
Sorry?
In additional mitigation, there are two of them. First one is restricted access, and second one without restricted access.
Which one? Where it is?
Column 6.
Mm-hmm.
So there's restricted access. Can you see it? Additional mitigation, comma, restricted access. What does it mean?
I'm not sure why they added that one. It's like an example from internet, but probably restricted access to different initiating causes. For some of them, they have it. For some of them, they don't. But in general, there is no need to pay attention for this part because additional mitigation is a specific data for someone who did this specific LOPA. But this one will actually shows you the probability of failure on demand, PFD, for your specific IPL. Sorry, that one can be. Okay, so sometimes in addition to your IPLs, there are some different ways of mitigations, which are also counted. That's really depends on the type of company you're working for, and they add this data like you are having restricted access to this area. So the probability of someone being there at this moment is really, really low. That's why you take a credit to this as an additional layer of protection. So you're correct. You are actually really correct. And I didn't pay attention for that. I just actually give it as a simple way of IPL, which have a specific probability of failure on demand. So here we don't have any IPLs in general. We are saying that we don't have any. We have one here, control systems, which we take credit for. And this like additional mitigation, that different way of additional mitigation. And restricted access is restricted access to this area, saying that your probability of being in that area is really low, so we can take it into account as additional safeguard.
Oh, okay, it's clear now. Thanks.
Welcome. So that was my confusion. Any other questions? So from me, that's it, because that was the last slide of the session with all the explanation about the HAZOP and LOPA studies. At this moment, you can understand it much better. So further, when you will be working in the industry, this will be really helpful for you.